So I will go here in the push, and then I will create the first new head. Okay, so I already got the item here. So I will use final stack node. So what we are doing is that we are creating this new head first. Let's go to new stack node, and I will pass the item here. So here we are just creating this stack node for the new head which we are going to push on top of it. Because in stack, as we know that whenever a new item is added, it's always added to the top of the stack. So this would be our new head, but we have to do it atomically as mentioned in the compare and swap algorithm. Okay, so now I will take the stack node of say old head. I will just take a reference here first. Okay, and now inside that I will create a do while loop. Here I will check what is there in the top right now. So this is how I get it. So I'm using an atomic reference here. So by first of all, I will check what is at the top of it and mark it as old head. And we are going to set this new head again atomically by doing this set next. And I will point this old head. But here we'll only do it until we have got the top exactly same as. So I will do compare and set old head to new head. Okay. So this is all about this algorithm. Okay, so let me explain what we have done. So first of all, we created a new head here. And suppose there is one thread which is doing this, which is already entered push here. And it has got a new head for this new item, for this item that is passed as an argument. Then we check this old head first. So we get the top old head, and then we set the new head to be the next item, because we are going to put this new head on the top of this old head. So that's why we put new head dot set next as old head. But this we will only do it until we ensure that we compare and set this old head with the new thread. What it means is that suppose if there is any other thread which is coming here and it is trying to do the same stuff, and it gets this old head and it updates it at this point. Before it reaches here, before you're actually setting it, it reaches this point and it already gets the old head and set it to the new head. But for the previous thread which has already entered here, it will see that this old head is not pointing to the same thing that it has got before, because compare and set here would be failing here. So that's why this algorithm will only work for the old thread unless the old head which it has retrieved here has not been updated by another thread. This is what this algorithm is saying here. Pushing an item to the stack is done by first taking the top of the stack old head. We took the top of the stack as old head and placing it after your new item to create a new head. So this is the operation that we're talking about. You then compare the old head to the current head. Now the old head we are comparing to the new head, right? This is what we're doing. If the two are matching, then you can swap old head to the new one. If not, then it means another thread has added an item to the stack. This is exactly what we have done here. So we are doing this operation that you then compare the old head to the current head, and if two are matching, then you can swap old head to the new one, not otherwise. This is where this while condition is coming. We are comparing this old head to the new head. So this is exactly same as what we have got in our tribal stack. So let's implement the same thing using pop. So in the pop, again, because we have to check whether our top is not manipulated by another thread. So I will create two pointers here. One is for the old head and another for the new head. We have to keep comparing this unless we ensure that this thread is pointing to the same old head as it was before. So again, we will use the do while loop here. Give a do, and I will check old head is equal to top.get. Okay, And there is one condition, right? If it's null, I mean, if the stack is empty, then in that case we have to return. So if old head equals null, then return null. We are not throwing any exception, we just return null. Otherwise, we set new head is equal to old head dot get next. Now here again we have to check this while condition, that top dot compare and set, it should be exactly same as old head with the new head that we have created. Okay. And once this is all set, then we ensure that this operation is ensured that there's only one thread, the current thread, which is updating it to the old head to the new head, because we have to, once we pop any element out of it, the top, if this element will be gone, and the top will be pointing to the next element, which is next to this. So top will be pointing to this T here, for example. So this is what we are doing it. We are old head dot get next. We are pointing this to the new head. So the new head would be this T. And then we return the old head dot get data. So this is what we return afterwards, after we pop the element. So again, let's revise this. Now we in the pop operation, same as push, right? So push, we are always trying to like see whether the old head and the new head are same after doing this update of the new head. So first of all, we get this old head similar to this one, and then we set the new head to the set next to the old head. Okay. So here we are doing the opposite way, because we are going to update the pointer for the top from old to the new, because we are going from up to down. That's why we are taking the next of this F, which is D, and assign it to the new head, because the new head would be pointing to D. And we do it all using this compare and set operation, because we need to ensure that no other thread has changed it until we last time visited this old head. If any other thread has already popped it, then old head would be also updated, and this would not be same as the same old head which was from the previous thread. And once all this operation is guaranteed to work, in that case we can ensure that our thread is not is pointing to the same old head after this while operation. So we'll just return this. So this is about pop. Now for peak, it would be very simple, because we are not updating any value here. We're not manipulating the top. So we don't need all this compare and set operation here. So what I will do is that for the peak, I will just check if top dot get, if it's equal to null, then we simply return null. Otherwise, just return top dot get data. That's it. Because we're not going to manipulate anything here for the top pointer. That's why we don't need compare and set operations here. So this is like quite a handful, but if we again think about this compare and swap operation, it's quite simple to understand, as explained here in the Wikipedia. So here we are just thinking that whenever we are updating the top pointer, what we are doing is that the top is like the old head that we have discussed here. So this top is actually the old head. And what we are trying to ensure here is that whenever we are doing a push operation or a pop operation on this stack, we ensure that, because in both of these operations, we have to manipulate the top. For pushing, we have to update the top pointer from here to the top, to the new head. And similarly for pop, we have to remove this item at the top and then move top to the next element. So top is being updated here in both push and pop, which is what we are trying to do it using SAS operation. So SAS operation is very, again, this old, we can refer this top pointer as P here, and old head and the new head for both push and pop, as we just discussed. Now we always ensure that this top is always pointing to the old head until we are going to update this top to the new head. This operation is done in a single step. That's why we are using compare and set. This is what we have implemented using this tribal stack algorithm. The tribal stack algorithm is exactly same utilizing this compare and swap as we just discussed. The only thing is that we can treat this P as top, our top pointer, old as which is actually atomic reference that we discussed here. So atomic reference here is top, which we are talking about this P pointer, and the old is our old head, and new is our new head. And because we are updating this top accordingly, that's why we are compare and setting this old head to the new head in both of this pop and push. We are always ensuring that this top is always pointing to the old head at the beginning of the operation. But whenever you get this top dot get old head, and the time that we set it to the new head, the current thread is always pointing to the same old head. It is not pointing to any other thread. This is what this algorithm means. If P is not equal to old, our pointer has been any other thread has updated this old. In that case, we have to return false. Otherwise, we have to update it. And this is where this while loop comes. So this was about the algorithm now. Now let's write some unit tests.